Number 37. Last week you bought 3 candy bars and 5 bags of chips for $8.50. This week you bought 4 candy bars and 8 bags of chips for $13. How much did each bag of chips cost? How much did each candy bar cost? And explain how you use your graphing calculator to check the reasonableness of your answer. So the first thing that we don't know, well actually two things we don't know, are the price of a bag of chips and the price of a candy bar. So I let X represent the price of a bag of chips and Y represent the price of a candy bar. So let's go back to the first sentence where it talks about our first situation, and let's see how to write our first equation of our system. Last week you bought 3 candy bars. Well, candy bars, I bought 3 of them, and they're $Y each. So 3Y plus 5 bags of chips, so 5X, was $8.50, so equals $8.50. This week you bought 4 candy bars, so 4Y, and 8 bags of chips, so 8X, and it cost you $13. Now I have to solve the system of equations. So I look at this, and it looks like elimination might be the easiest method to use. I'm going to have to multiply both equations by some number. So what I'm going to do is I'm going to choose to eliminate the Y values. I'm going to multiply this top equation by -4, which would make that -12Y, and I'm going to multiply this bottom equation by +3, which would make this +12Y. So let's go through and multiply the whole top equation by -4. So I would get -12Y minus 20X equals -34. And this bottom equation, 12Y plus 24X equals 39. Now my next step is to add them together for elimination, because the Y's will eliminate. I will get 4X equals 5. And if I divide 5 by 4, since I'm talking about money, I can use it as a decimal and not as a fraction. I get $1.25. So I'm going to take that and plug that back into my original equation, either one, and see what Y equals. So I get 3Y equals 5 times 125 is 625. I'm sorry, 3Y plus 625 equals 850. Now I'm going to subtract 625, and I get 3Y equals 225. And if I take 225 and I divide it by 3, I get 0.75. So part A says, how much did each bag of chips cost? And the bag of chips was my X. So a bag of chips cost $1.25. How much did each candy bar cost? And my candy bars were my Y's, which is 75 cents. Explain how you can use your graphing calculator to check the reasonableness of your solution. So what I can do is I can take my graphing calculator and I can substitute back in the values for X and Y into my original equations and make sure that it checks out. So if I type in 3 times 0.75, which is my Y, plus 5 times 1.25 and hit enter, I get 850 equals 850, which is true. If I do the same for the next equation, I get 4 times 0.75 plus 8 times 1.25, and I hit enter and I get 13. So I've justified that when I substitute back in my values for X and Y, that it works out. So let's say I substituted the values of X and Y into my calculator. To make sure the solutions worked. Alright. Number 38. Ali and Abdallah went to Taco Bell for lunch. Ali ordered 4 tacos and 2 super burritos for $10. Abdallah ordered 6 tacos and 1 super burrito for $9. How much did each taco cost? How much did each super burrito cost? And explain how you can use your graphing calculator to check the reasonableness of your solution. So the two things we don't know are what our variables are going to represent. So let's let X represent the price of each taco. And then let's let y represent the price of a super burrito. So first, we have Ali's situation. He ordered 4 tacos and 2 super burritos for $10. So he ordered 4 tacos at X dollars each, plus 2 super burritos at Y dollars each, equals $10. Abdallah ordered 6 tacos, so 6 times the price of a taco, and 1 super burrito, so plus Y, for $9. Now I have to solve, and I think that elimination will be the easiest for this one also, because if I multiply this bottom equation by -2, I'm going to be able to eliminate the y's very easily. So what I'm going to do is I'm going to rewrite this off to the side. So -12x minus 2y equals -18. And I'm just going to rewrite my other equation right above it so they're nice and lined up for elimination. Now what I'm going to do is I'm going to add, because that's my next step, into which the y's will eliminate. And I get -8x equals -8. Divide by -8, x equals 1. And if I go back and I substitute that into either one of my 2 original equations, I'm going to get what y equals. So 6 times 1 plus y equals 9. Subtract 6, and I get y equals 3. So how much did each taco cost? And X was the price of each taco, so each taco cost $1. How much did each super burrito cost? Y was the cost of a super burrito, and that was $3. Explain how you can use your graphing calculator to help you check the reasonableness of your solution. Very similar to the one that we just did. So I'm going to go back to my original equations and say if he bought 4 tacos at $1 each, and I'm substituting in 1 for X and 3 for Y, plus 2 super burritos at $3 each, and hit enter, that equals his total, which was $10. Similarly, Abdallah ordered 6 tacos at $1 each, plus 1 super burrito at $3 each, and that was $9, which was the price that they said he paid for his lunch. Okay, so we can say I substituted the value of X and Y into my calculator to make sure the solutions worked. Number 39. Given x plus 5y equals 6, and x plus 3y equals 8, and 3x plus 15y equals 18, and 5x plus 15y equals 40, explain why these 2 different systems give the same solution. So the first thing that I notice when I look at this first equation and this first equation, and this second equation and this second equation, is that if I multiply this equation by a value, I will get this equation. And if I multiply this equation by a value, I will get this equation. So ultimately, they're the same equations. It's the same system, but in a different form. So if I multiply this top equation by 3, everything would be exactly the same as this first equation over here. If I multiply the bottom equation by 5, everything would be the same as this equation right here. So explain why these 2 different systems give the same solution. The first system is the same as the second system, if you multiply the top and bottom equations by a constant. And now I'm going to solve it. So let me take that first system because that looked a little bit easier to work with. And I'm going to use elimination. So I'm going to multiply the whole top equation by -1, so then I'll have a -1x and a +1x, and they'll be able to eliminate. So ultimately that just changes the signs. So this is what I'll have. And I'm just going to rewrite my other equation right underneath it, and I'm going to add them together. This will eliminate. I'll get negative 2y equals 2. Divide by negative 2, y equals negative 1. If I take negative 1 and I substitute it into one of my original equations, I can get what x equals. So let's just enter it in the first one. X plus 5 times negative 1 equals 6. If I add 5 to both sides, 6 plus 5 gives me 11. So my solution to this problem is 11, negative 1. Let's just draw a line here to kind of separate this. All right. Next one is very similar to this one that we just did. So it says, number 40, given x plus y equals negative 2, 2x minus y equals 11, and 5x plus 5y equals negative 10, negative 10x plus 5y equals negative 55. Explain why these two different systems give the same solution. So very similarly, when I look at the top equation of this one on the left and this one on the right, they look the same to me, except for this one is multiplied by 5. So if I took this one and I multiplied it by a constant, which is 5, it would give me the exact same equation over here. Similarly, if I multiplied the bottom one by negative 5, because that would give me negative 10x, positive 5y, and negative 55, I get the same equation. So explain why these two give the same solution. The first system is the same as the second system if you multiply the top and bottom equations by a constant. And let's solve. So once again, I'm going to use that first system because it looks like it's already set up and ready to go for elimination because I have opposite coefficients for the y's. So if I add these together right away, my y's eliminate. 1x plus 2x is 3x equals 9. If I divide by 3, I get x equals 3. I'm going to go back to one of the originals, like the first original, and I'm going to substitute in 3 for x, so 3 plus y equals negative 2. If I subtract 3, I get y equals negative 5. So my final answer as an ordered pair for this problem will be 3, negative 5. And that's my solution right there, 3, negative 5.